Hi, Jonathan Godfrey with Onsite Wastewater Professionals. And I have the privilege today of being joined by Stephen Berkowitz, longtime engineer with the state of North Carolina. And now Stephen is working with SIRCAP.
Yeah,
but
part-time.
Part-time with SIRCAP. Okay. Part-time in retirement. But today we're going to talk about control panels, and we're going to talk about maybe some stuff in the past and kind of thoughts to the future. But quick conversation on control panels today. Stephen Berkowitz. Stephen, to start this off, you've been in on-site wastewater how long?
Well, I was the first engineer with the program starting in October 1982.
82.
Yeah.
What did a control panel look like in 82? Like when you started, what are we talking about?
Well, it was really all over the place. We would have, one of my early memories is looking at systems that had junction boxes inside. The standard was to put the junction box inside the pump tank. And I remember inspecting Linville Falls National Park site. The pump was burned out, and you opened up and saw this completely corroded junction box. And then the panels were, a lot of our pump systems are on the coast, and the panels would last, 1 or 2 years before the salt corrosion.
They just weren't sealed at all at that time.
And it meant electrical code. Electrical code was only
a 7R box or
3R.
3R,
3R, or even a 3R was rain proof, and you can rain directly on it. So we really and then with the piggyback floats, sometimes the piggyback switches were inside the riser, and they wouldn't last very long. We some of the inspections we did back in the 80s in Union County found a number of LPP systems that put in with corroded controls that weren't working. So the first step was to.
Was that legal then to put them in? Was there any rule when you first came on that prohibited the junction box or?
Well, the only codes that, the electrical code was the only thing that applied, but rarely would the electrician actually look at what was done inside the septic system.
We still live that today.
So, and early on, we put, I think I believe in the 1990 rules, it was the last major rewrite of the rules prior to what's happening right now. And I think we were able to get into the 1990 rules requirement for a NEMA 4X box, for the requirement for, we couldn't get in control panels. We did have one of the big things was to require that you would have to be able to manually operate the pump. So it was hard to argue that you couldn't do that with a piggyback float.
Certainly.
But to not have any of the wiring inside the pump tank. So that was kind of a major improvement to at least get no junctions, no splices inside the pump tank. And that was instituted, I believe, in the 1990 rules. And also require either a control panel or at least if a manual disconnect in a NEMA 4X box. So we got the NEMA 4X into the rules. We still had a lot of conflicts where the electrical code will allow a lesser but the health department. So that involved a lot of conversation back and forth because the electrical inspectors in some counties were still approving things that the health departments would deny.
Sure.
So
was there a push in that 90s rules to actually have a more inclusive control panel requirement, or?
I think there's been a desire to have it for a while.
That's neat to kind of get that context.
Yeah, I mean,
well, it only took how long?
Well, I mean,
30 more years.
Well, I know Joe Lynn was our regional specialist who kind of headed up a rule-making effort, and we would probably at least 15 years ago there were drafts that included control panels as a requirement. But and then as you had more systems, like we did have control panel requirements for the large systems, for the systems that were 3,000 gallons. And we saw, I mean, that was somewhat of a result of problems with,
Right.
in 1992, the health departments inherited responsibility of public and community systems. And there were public and community systems going in from 82 to 92. That was that DEM, DEQ's predecessor, Division of Environmental Management, had permitted.
Would they have had engineers associated with
They
them?
would have had engineers, and there was just a whole variety.
But even with an engineer, it didn't guarantee that we were going to get.
No, I mean, I would say
Control
that the NEMA 4X aspect of it was a major advancement.
That's awesome.
And then the idea that the panels would have, when we got to duplex panels, we were able to get in there that you at least had a lapse meter, because for troubleshooting and for the operator of those systems, that was one of the main things that they would have to keep track of, was when they do our monthly inspections, to record.
Sure.
Problem we had, and we still have it to some extent, is we have these bells and whistles, but an operator is recording the elapsed time clock meter, and it might be, I would expect some systems that they've been recording it dutifully for like 6 months, and it was showing you that the pump wasn't working.
It was screaming that there's a problem, but we didn't
they
respond.
were dutifully recording it and logging it into the logbook. So it's only as good as the tool that you use.
Right. We can play a big role there in trying to, we as an industry can, in trying to increase the level of education.
Right.
As we move forward, so we've had that history where we started with the 3R. I've seen those panels a little scary to put your hand in after a number of years, right?
I guess another thing I should point out is that to make sure that the floats were separated from the discharge pipe, because a lot of times the pump might be okay, but the floats are going. So the concept that that you can separately have access to the pump and have access to the floats, and so that was another thing that was instituted in the 1990s.
That seems really common sense, but when I go to other states, that is not a concept that's still applied today. The idea of attaching floats to discharge assembly is still done in parts of the country.
And so you have to remove the pump, and then even the floats, having them accessible, like the concept of a float tree is probably actually some installers or operators develop some of the ideas that we use now for a float tree, so it's easy to access. You don't have to, and the whole idea is not, you want to be able to manually operate. You want to be able to tell whether to set up the dosing volume, but not have to go down into the tank. So you need ways that you can access things either for maintenance or even the initial inspection to see that it's working properly. So you want to be able to, so the piggyback, it met the requirements, but it's not ideal to have to take the piggyback plug out of and plug it in.
If you want people to use tools, the one way you can guarantee they won't use them is make them hard to do, right? Mm-hmm. So the more steps, so if you've got to service the floats, to inspect the floats, if you had to pull pumps and things like that, it was just never going to get done. So making things accessible is a win for our industry. So you got perspective on the past, where we started out in the world where it was a hodgepodge of anything goes, wild, wild west. And we come into the 90s and we've got a more solid footing where we've got at least a NEMA 4X box and a piggyback. As the new rules what were ATD rules have been in the work, so to speak, for years,
right?
More than a decade. Is that fair?
Oh, yeah.
Maybe close to 2 decades.
Yeah.
They've been thought about. What was the push to push the control? When we focus in on that control panel portion, what was the push to drive it forward?
I think, one of the pushes is, I think industry has gone in that direction.
Absolutely.
I mean, there's still some counties that probably still, and they can't deny a piggyback float. But I think the majority of counties, just from our intern training, the majority of counties are already using control panels. And I mean, we got to remember that we look at this, or the on-site program looks at this as a permanent part of infrastructure. It's not just a temporary solution. So as part of that, you need to have a system that's has long-term operation and maintenance capability. So I think industry has accepted that. The health departments have seen, and I think ultimately the user has seen, it has more longevity to it than having this piggyback type float switch.
You're exactly right. In the markets where pumps are really common, so let's go to Carteret County, where a lot of pump systems, even without state regulation, the market has kind of driven.
Brunswick County.
Yeah, Brunswick example. They've driven a
Wake County, some counties with local rules.
Local rules aside, but the market has kind of driven this new, better technology has created a foothold in the market. So, if we drill in further into the 18E rules and we say, Stephen, what is an area of the requirements that'll be put in place in the new rules that you're most proud of, that you think that was a real victory for control panels? I know there was changes on things that seem small, changes to how we adhere the floats to the float tree. Now they have to be removable and adjustable. So maybe an elimination of zip ties and black electrical tape, maybe stepping up there. And then there's requirements to be a little bit higher off the ground where we can more user-friendly. The 50 feet clear line of sight. Is there an area of the new control panel rules that you say that's one that was worth fighting for? And that one is
I think another thing that, to actually have both the cycle counter and the elapsed time meter, that you can learn a little bit from one, you can learn a little bit from the other, but the combination of the two is really very
fantastic,
very, very beneficial. And yes, it does add a little bit of cost to the panel to have both of them, but then now, of course, that information is both usable for a system that has an operator, but it's potentially, with training of the homeowners, they could utilize that information too, just like knowing what their water use is in a water meter. They can see that they can be trained to see what those numbers mean, and over time to see if you're having a leak problem or a groundwater infiltration problem, or if you're pumping to a system that's not that's starting to show clogging. So you're going to see the time for
runtimes increase,
increase, and then still having options for for an alarm circuit to have the alarm functional if the pump goes off. I mean, there's some just basics that are critical that I think most of the basics that are needed are in there.
Right.
And there's still a lot of varieties that meet the code.
Right. I think you and I shared the idea that the improvements in 18E were worthwhile for control panels and needed, right?
Right. And I think industry has accepted that too. It's not, it's not that, that big the longevity, these pumps can last for 10, 20 years. And, I've been in systems at 15 plus years, the pumps are doing fine. And I think that having a good protective box, still having operational, that you can test the system without having to go into the system, making sure that you have a functional alarm, even though
safety's not a bad thing to think about with our profession and our field personnel and actually homeowners. Always had this concern or thought with a piggyback float that in a way we can ask that float to do more than what it's rated to do. We're asking it sometimes to carry full voltage and amperage of the pump, and our new modern control panels they have safety features, whether it be breakers,
well, the
fuses.
other aspect of it is that a control panel, to meet current code, has to be third party certified to do it. And just this with the the untested submersible, and that has become up. Does certification is really valuable to the industry? And I think almost everything else in the home has some kind of third-party certification that at least meets that. And that's primarily for a safety standard. It's not necessarily for the performance. You can probably have a UL certified panel that doesn't do everything that's official for the. So you have to have both. You have to have both a safety standard and minimum performance requirements. So it's a fine balance that a code has to meet, not be overly burdensome
on the private sector. So let's look out to the future and kind of think about what control panels could be. You've seen dramatic shift from where you started to where we are now, and the technology that'll be required in the 18E rules won't exactly be requiring, space age technology or even current capabilities. Are there other aspects of control panels that you think will be employed or could be employed or should be employed in the future?
Well, I think we're with all this artificial intelligence, AI, becoming a more commonly word, taking the information that the panel is delivering and in a real-time basis, can the operator, and even more important than the operator, the homeowner is dependent on this system.
As we talked about earlier, the vast majority of control panels are going to be deployed in places where there is no operator.
Right.
The homeowner is effectively the operator.
The operator, and I mean, just the parallel is if the home has a water, has a water meter,
right? And
the water meters have gotten smarter and smarter. And unfortunately, the main reason that they've gotten smarter and smarter is to benefit utility that's reading the meter and hasn't been translated into giving the homeowner, because the utility wants to make sure they can easily read the meter, right? And as long as they get paid for whatever.
For billing purposes,
purposes. But the homeowner needs to have information that the panel is delivering, and for water meter, but certainly for a wastewater system. Can they know that there's, that the field is showing signs of clog?
And not just
the pump is running longer, or
not just have that data piece out of context, but to translate it into a way a homeowner can understand it and say.
So I think that's the next step, is to have some more remote monitoring capabilities that communicates not just to the operator, but that communicates to the homeowner, and done in a simple enough way that they can understand that, hey, there's something going wrong and we need to
call somebody.
Again, we want this technology to be a sustainable, ongoing technology.
Permanent infrastructure, right?
And so if they get a warning that there's, the pump is using too much amperage, or that it's getting close to its life cycle, but well before the sewage backing up into the house. I think that's there'll be. And there's some innovations already on the market, some telemetry type systems that when that becomes more economical and there's enough competition, that I think we'll see more of that.
And I guess last thing is that, are there any lessons that we learned in the past that we need to not, if you're younger in this industry and you didn't get to experience the 80s, 90s, and you don't know why decisions were made in the way they are, you may think there was just an arbitrary decision. Were there key lessons in the control panel world or anything like that?
I think one of the things that the trade-off between access and aesthetics. Do we want to have it so people don't just like to see a riser in their house? But I think with education, you can say, well, there's a good reason to have access there, and you can maybe do some aesthetic things around the riser, around the panel.
I don't think people complain that hard once they understand the purpose, right?
I think
if they buy into the purpose.
And so it's a process to have homeowners. And I think the more education you can do and the more knowledge the homeowner has of what he has, rather than just just forget about it.
Thank you. That's awesome, Stephen. I appreciate you taking a few
Okay.
minutes to talk about control panels today.
All right.
Onsite Wastewater Professionals, and more to come, guys. Thank you very much.